Howdy. Chapter 4, Two-Dimensional Motion. In Chapter 2, you learned how to describe the motion of an object moving along a line, one-dimensional motion. Of course, in the real world, there are 3 dimensions, so you will have to learn about more general motion. The new element introduced when you consider motion not along a line is the vector character of all the quantities: position, velocity, and acceleration. Since paper is 2-dimensional, and there is no essential difference between 2- and 3-dimensional motion, most of the time only motion in a plane will be considered throughout the book. The chapter can really be divided into 2 parts. The first part just combines what you have learned about one-dimensional motion with what you know about vectors. Make absolutely certain that you have mastered all the material in chapters 2 and 3. Instead of specifying an object's position by saying what is its value of x, we will specify the position of an object that moves in the xy plane by a vector from the origin, which we choose, to the object. This vector is called the position vector. The velocity is now also a vector, as is the acceleration, since they have direction as well as magnitude. These vectors are defined by the vector equations v is dr dt, a is dv dt. Writing all vectors in terms of unit vectors and components is shown to result in a 2-dimensional motion problem just being a combination of 2 one-dimensional problems. You should definitely understand how this comes about. It involves using the fact that the unit vectors do not change with time, and therefore their derivatives are 0. Another important element of the derivation you should pay particular attention to is the mathematical step that leads to having a vector in the x direction equal to a vector in the y direction. Of course, this can't be true unless the vectors have 0 length, since for 2 vectors to be equal, they have to have the same direction and magnitude. At this point, you should be able to start with a simple time-dependent acceleration vector, integrate its components to find the components of the velocity vector, integrate them to find the resulting x of t and y of t. You should be able to relate the constants of integration to physical quantities such as the values of x and y at t equals 0. If you have trouble doing this, go back to one-dimensional motion since it is the same thing. Expect a quiz such as exercise 3 or problem 3. The second part of this chapter involves solving actual problems using the algebraic equations that result from integrating the components of the acceleration. The first step should therefore be to write down the components of the acceleration and integrate. Many problems have constant acceleration, and there is a temptation to memorize the equations for that special case if you have not already done so in high school. X of t is axt plus vx of 0, x of t is 1/2 axt squared plus vx of 0 times t plus x of 0, etc. The danger is you will then use these special equations, called the handy-dandy equations in the book, in problems where the acceleration is not constant. Do not be a victim of this crime. There are an infinite variety of problems where the idea is to figure out how you can make one object collide with another. You might be interested in designing an anti-missile system to intercept incoming rockets and save a city. More important might be to design a system to intercept an incoming asteroid and save the planet. Most important is to marvel at a quarterback calculating the required initial velocity vector in order to complete a pass to an accelerating receiver. He needs to do this without benefit of a cheat sheet filled with formulas, while avoiding the onrushing 300-pound lineman. You need to realize that the acceleration vector for the ball is not simply vertical with the constant magnitude g because of air resistance, and that the receiver also has a complicated acceleration vector. The example problems you must solve in the book are far simpler than the actual problems the quarterback has to solve, so you should be amazed whenever a pass is actually completed. You should do all the problems in Chapter 4 to become expert in obtaining the appropriate equations to be solved and in translating conditions expressed in English into equations. For example, for a pass to be complete, there has to be a time, call it cap t, at which the x and y components of the ball's position vector are equal to the corresponding components of the receiver's hands. Another example of two objects colliding is the subject of exercise number 7. You are asked to find the angle at which to aim a gun in order to hit a falling object. We can do the experiment to show that it really does work. Okay, so this experiment is actually called shooting the monkey, but it's not a monkey. What we have is a metal can which is held in place by an electromagnet. And I put this ball in the launcher, load it up, and now click this to fire. And there's a photocell here. When the projectile passes the photocell, it turns off the electricity so that the electromagnet is turned off, and the monkey, or in this case a can, falls down. And the question is, can I kill the monkey with this gun, or hit the can? And at first thought, I would say, what are the odds that I can figure out how to aim this thing without knowing the details of the mechanism and still hit the can? How many think I can hit the can? No. No way. Okay. Summary. The position, velocity, and acceleration for an object are now represented by vectors. By choosing the x and y axes to be perpendicular, one can obtain two sets of equations, one relating all the x components of these quantities and one relating the y components. You must be able to find the components of the acceleration vector in order to integrate, as was done for one-dimensional motion. You must be able to start with a given initial velocity vector, find its components, as these are the quantities that will enter the kinematic equations. You need to practice integrating accelerations, finding initial values of the components of position and velocity, and setting up the conditions, usually expressed in English. When you realize that all the problems are essentially the same, whether they involve shooting an escaping terrorist or a lion catching a deer, you will have mastered the material. Gig 'em.